This section presents the core challenge. We're given that x and y are positive whole numbers, and 3x plus 2y is less than 15. Our job is to figure out which of the multiple choice options always has to be true, given that first condition. This option suggests that x is always less than 5. Let's see if we can find any example where x is 5 or greater, but still keeps 3x plus 2y less than 15. If x is 5, then 3 times 5, which is 15, plus 2y must be less than 15. That means 2y has to be less than 0, which is impossible since y has to be a positive number. So, yes, x must be less than 5. This option is correct. This option proposes that x plus y is always less than 6. I'll try to find a situation that breaks this. If x is 2 and y is 4, then 3 times 2 plus 2 times 4 equals 14, which is less than 15. But 2 plus 4 equals 6. This means x plus y can be equal to 6, so this option doesn't always have to be true. Therefore, this is incorrect. This option says y must be less than 8. Let's test it. If x is 1, then 3 times 1 plus 2y less than 15 means 2y is less than 12, and y is less than 6. But, if x is 4, 3 times 4 plus 2y less than 15 means 2y is less than 3, which implies y is less than 1.5, which can only be 1 as y must be a positive integer. That shows y doesn't always have to be less than 8. Therefore, this is incorrect. Here, the suggestion is that 2x plus y is always less than 10. Let's look for a counterexample again. If x is 3 and y is 1, then 3 times 3 plus 2 times 1 equals 11, which is less than 15. But 2 times 3 plus 1 equals 7, which is less than 10. However, if x is 1 and y is 4, then 3 times 1 plus 2 times 4 equals 11, which is still less than 15. But 2 times 1 plus 4 equals 6, which is less than 10. I can't find a case where it's not true, but that doesn't mean there is no such case. This option doesn't always hold true. Let's check if this inequality always holds true. I'll test a few examples. If x equals 1 and y equals 4, then 3x plus 2y equals 11, which is less than 15. In this case, x plus y equals 5, which is less than 6. However, if x equals 2 and y equals 4, then 3x plus 2y equals 14, which is also less than 15, but x plus y equals 6. So, this inequality doesn't always hold true. Let's test this one too. Suppose x equals 3 and y equals 1. Then, 3x plus 2y equals 11, which is less than 15. And, 2x plus y equals 7, which is less than 10. But, what if x equals 4 and y equals 1? Then, 3x plus 2y equals 14, still less than 15. But 2x plus y equals 9, which is also less than 10. However, if I try x equals 1 and y equals 4, 3x plus 2y equals 11, less than 15. But 2x plus y equals 6, which is less than 10. It seems like this inequality sometimes holds true but not always. I'll show you why this option must be true. If x were 5 or greater, then 3x would be 15 or greater. Since 2y must also be a positive number, 3x plus 2y would be greater than 15. But we know that 3x plus 2y is always less than 15. That's a contradiction, so x must always be less than 5. Let's find another counterexample. If x equals 1 and y equals 4, then 3, 1, plus 2, 4, equals 11, which is less than 15. Here, x plus y equals 5, which is less than 6. But if x equals 2 and y equals 4, then 3, 2, plus 2, 4, equals 14, which is less than 15. Now, x plus y equals 6. This inequality fails the always true test. I'll show you why this isn't always true. If x equals 3 and y equals 1, then 3x plus 2y equals 11, which is less than 15. Then 2x plus y equals 7, which is less than 10. But if x is 1 and y is 4, then 3x plus 2y equals 11, less than 15. but 2x plus y equals 6, less than 10. However, other examples may not satisfy this inequality. It's not a guaranteed true statement. Only option A, x less than 5, is always true. If x is 5 or greater, you'll never find a positive y value to keep 3x plus 2y less than 15. That's the winner. This is the core inequality we need to analyze. It tells us that 3 times x plus 2 times y must be less than 15. We're dealing with positive integers for x and y, so we're looking for whole numbers greater than 0 that satisfy this relationship. I'm testing if x is always less than 5. If x were 5 or more, then 3x would be 15 or more. Because 2y must be a positive number, the total 3x plus 2y would be greater than 15. So, x must be less than 5 for this inequality to hold true. Let's see if x plus y is always less than 6. I can find examples where this is true, but I can also find examples where it's false. For instance, if x equals 2 and y equals 4, then 3x plus 2y is 14, less than 15. But x plus y is 6, not less than 6. This means that this inequality isn't always true. I'll check if 2 times x plus y is always less than 10. Similar to the previous example, I can find examples where it is true. But if I take x as 1 and y as 4, then 3x plus 2y equals 11, which is less than 15. But 2x plus y equals 6, which is less than 10. However, if I choose x as 4 and y as 1, then 3x plus 2y equals 14, which is less than 15. But 2x plus y equals 9, which is less than 10. Therefore, this inequality is also not always true. Let's examine if y is always less than 8. I can find situations where this is true, but also cases where it is false. A large value of x might restrict the possible values of y such that this condition is not always guaranteed. This is just a restatement of the problem. We're analyzing the inequality 3 times x plus 2 times y is less than 15. This section lists the various inequalities I'm checking to see if they always hold true given the original inequality.